Hi, in this video, we're going to talk about logarithms. So logarithms is another form of exponent. See, we know that exponent function is defined x equal b power y. So here the power, this y, we can express in terms of log. The b is base and y is called power and x is the value we obtained for the exponent function. So better you can keep this name. So what is b is base, and the y is called power, then that x is called value. For exponent function, we have value, so x is a value. So for this exponent function, we can express, the power will be expressed in terms of log. So that is y equals log of x to the base b. Okay, so the power is nothing but logarithm of the value of x with the base b. So here x and b are positive numbers and b is not equal to 1. And we should read in a proper way. So logarithm of x to the base of b. Log x, simply we can read log x are basically logarithm of x to the base of b. And we have two types of logarithms. One is common logarithm and another one is natural logarithm. Common logarithms having base 10. So log x means the base, here we have 10. So sometimes no need to mention with the base. So we have a question without base, which means the base is having 10. And the second one is natural logarithm. The base is e. E is a mathematical constant. It's like a pi. So 2.718 is an irrational number. And we have fundamental laws of logarithms. The first three rules we're going to apply. Log of a times b times c to the base b is log a plus log b plus log c with the same base. And log a divided by b is log a minus log b. So it's simple to remember. If you have times here, then it will be split into with plus. So here we have plus because of times, and here we have divides, so we have minus here. And the third rule, log a power n. So this we can keep that power n, it is in the before the function, n times log a, n times log a, right? Okay, only the three rules enough. Now change the following from exponential form to logarithmic form. How to change exponent form to logarithmic form? The first question we have, so here think about what is a base. This is 9. This 9 is a base and 1 is a power, and 9 power 1 is the value is 9. So you have to change exponent to logarithm function. First you consider the power. So the power 1 equals log of the value 9 with the base 9. Okay, I will explain with the second question. So here 5 is a base and negative 2 is a power. So we start with negative 2 always. So negative 2 is equals log of the value. Please write the value always log, and the base is 5. So base normally we always keep little down, not in the same line. Then 13 power 0 is 1. So what is the power here? 0. So 0 equals log 1 to the base 13. And similar way, a power 0 equals 1. So that 0 equals log 1 to the base a. And if you have any radical form, you need to keep in the the root format will become into power function like exponent with fraction power. So what is 3 root of 343? So that is 343 power 1 over 3. So now we can express that power 1 over 3 is equals log the value 7 with the base 343. Now we are looking for the reverse. Change the following from logarithmic form to exponential form. So we have logarithmic form, we need to change into exponential form. So for changing exponential form, always first you take the base. What you have the base. So you start with base. So 6 is the base. Then where is power? This is power. So the power you can fix now. That is equal to, and finally that equal to the value 6. It's simple. So always you consider when you change logarithm to exponential, consider the base first. So the base 8 and power is 0. 8 power 0 gives the value, it is 1. And similar way, what is 4 is the base, power -2 gives 1 over 16. And again here what is the base? 2 over 3. So 2 over 3 and the power 2. So 2 over 3 the whole power 2 equals the value 4 over 9. Then evaluate the following expressions rounded to 3 decimal places. So always we need to keep answer in 3 decimal places. So we know how to correct to 3 decimal places, rounded off or correct to 3 decimal places. And for this question it's very simple, but you need to do step by step. The steps are very important. You have to find the value of log of 12.7 by calculator. So that gives you 1.104. Then you need to find this natural log of 3.9. So that gives you 1.361. Okay, then you multiply the number. Like 2 multiply this number gives 2.202 and 4 multiply 1.361 gives 5.44. And finally, what is log of 5.8? It is 0.763 and divided by 0.763 will give you -4.241. So we need to do step by step. Don't do everything in the same step in the calculator. So that will give you a wrong answer. Always get, say for example, the second one, what is the value of e power 2? Get the value and correct to 3 decimal places. And then you have to find what is e power -2. Get the value from the calculator. Then do the subtraction in the numerator. After that, divided by 2, which gives 3.627, and finally multiply by 4. So this will give you exact answer. Next, we have to solve the logarithmic equations. So solve means we need to get the missing value x. What is the value of x? So we have logarithmic equation. So better you can change in exponential form, then we can obtain the value of x. So how to change? We know we already discussed how to change from logarithmic to exponential equation. So normally we considered base first. So 3 power, the power here, this is the power. So 3 power x equal to 81. Then you try to keep that number 81 in the exponent form. So what is 81? 81 is 3 to the power 4. So now look at this same base. That's why we have to keep this value with the same base. Whatever you have here, the same base. Try to give in the same base. So 3 is equal to 3. That the power must be the same. So x equal to 4. Similar way, the second one, the question. So 7, the base is 7. So 7 power x equal to 1. And try to write 1 in exponent form of base 7. So 7 power 0. Then x must be 0. Similar with the third question. So what is the base here? 5 and power x. So 5 power x equal to 1 over 25. And try to get in a base format. So 1 over 25 we can keep like 5 power negative 2. Or here you can keep what is 25? 25 is nothing but 5 square. So 1 over 5 squared will become 5 power negative 2. So x is equal to negative 2. Then again we have logarithmic equation. So change in exponential form. So what here, base is missing. X is in the base. So x power 6 equal to 64. So we have to get the base. So we need to delete the power 6. So take 6 root on both sides. So when you take 6th root of 64, this is we already learn, or you can use calculator. So you will get 2. The next one, the base we have 2 over 3. So what is missing here? The value is missing. So what is, you have to express in terms of exponents. So 2 over 3, the whole power 3, negative 3, which is the value x. And apply the power for both numerator and denominator, and apply this is negative 3, so we cannot simplify. So take reciprocal for both numerator and denominator. So this will becomes 3 power positive 3 over 2 power 3, which is x, and get the value. What is 3 power 3 is 27 and 2 power 3 is 8. Then we have a log of 2x minus 1 to the base 3 equal to 2. So here the value is missing. We have two terms, and it's okay. First you have to form as an exponential function. So 3 power 2 is 2x minus 1. And get the value. What is 3 power 2? 3 power 2 is 9. Then simplify the equation. We need to get x, so keep other terms in other side. So negative 1 we have to move on the left side. So 9 plus 1 will be 10 and divided by 2, which gives 5. Okay, thank you, and we will discuss the other topics in the next part.